Retrofit is one of the newest solutions to REST API communication in Flutter, building on top of the HTTP and DO packages and heavily inspired by the REST client for Android. In this video, we will be building API client using the Retrofit client generator, implementing all the CRUD operations, JSON serializable models, and custom HTTP responses, and then tie it together with the UI using state management package Riverpod and its error-safe Future Providers. In pubspec.yaml dependencies, add Flutter Riverpod, JSON serializable, and Retrofit. You will also need a build runner and a Retrofit generator for code generation. As for the REST API, we will be using free GoREST API. To demonstrate different Retrofit capabilities, our API client will have 4 different versions of GET and create, update, delete user methods. Let's start by defining abstract API client class and add part of client.g.dart for code generation purposes. Implement a factory constructor with DO instance and optional base URL parameters. Client needs to be annotated with REST API, which allows us to define base URL. It's up to you if you want to specify base URL here or when you instantiating the class. First request we are going to define is get of users. You can see the path here. Using online tool recbin.com, we can try calling this request, and on the right side we get the response in form of JSON object containing meta and data objects. Data is just list of users, and inside meta there is pagination containing some fields and links object. Based on this, we can later define all the data types needed for the responses. For now, define getUsers function, returning future of getUsers response, which encapsulates all the data we just saw. Don't worry about the errors for now, we will implement this data type later. Annotate this method with get, specifying the /users path, which will be added to the end of the URL. And that's all for this one. Going back to the API, we can see get request for getting specific user by adding path of users/id to the base URL. The response object we need to define encapsulates just the user instance since meta is null. Define getUser with ID method with different response object. Add get annotation specifying path users/id. Wrapping the ID in curly braces allows the use of path annotation, which inserts an ID inside the path string. To make use of queries, we will use the get comments request, which returns all comments, and using query, we can filter them by fields. By adding question mark post underscore ID equals 13, we now get only comments that are related to post 13. Define get post comments with new response object and annotate with get, specifying comments path. Then add parameter with query annotation, specifying name of the JSON field you want to filter by. You can add as many query parameters as you want, but for multiple queries there is one more option. Define a new method getPostCommands with query map and add parameter of type map of string dynamic and annotate it with queries. This way you can pass in map of the fields and values. Now for the post request, we will again use /users, this time to create user by passing in user object. Running the post method, we will get response with the user we just created. Notice that the ID we passed in was ignored and server generated its own. Define create user method, and since the response is same as for the get request of single user, we can use the same return type. Annotate with post and /users path. As parameter, add user instance, annotated with body. Post, put and delete request will require authorization using HTTP headers. Add headers annotation from HTTP package. Pass in map of string dynamic with single field of HTTP headers.authorization header and value being key, which you get from the website here. Create constant string with value of bearer space key and pass it in the header. For put method, we need to specify the user we are updating using their ID. Similar to getUser method, define updateUser with the same response type as getUser, annotated with put using the path with ID variable. Add same header for authorization, define ID parameter annotated with path, and user annotated with body. Delete method will be very simple. Define delete user returning void, annotated with delete using ID variable in path, and add header for authorization. Now that we have API client methods ready, we need to implement all the models and response objects. We can define them based on the responses. We have one response for getting list of users, one for single user, and one for list of comments, encapsulating objects of user, comment, meta, pagination, and links. Based on the responses we saw, we add fields for ID, name, email, gender, and status. Then define factory method for instantiating user from JSON object, calling user from JSON, which will be generated in the .g file. For the user, we also need two JSON method, which also calls generated method, using this keyword as argument. The responses of getting lists of users or comments include meta object. Again, define JSON serializable class with the part of meta.g.dart. Meta object then contains pagination, which we will define shortly. For this class, we need only two JSON method, calling the generated meta from JSON. Now define the pagination class, adding all the primitive fields as well as the links, and again from JSON method. The links class then holds previous, current, and next request calls for pagination, and from JSON method. Last model class will be comment. Each has its own ID, post ID, name, email, and body. We will need just from JSON since we won't be posting any new comments. Additionally, post JSON ID has a different name, so use the JSON key annotation to tie the fields together. Now we are going to need the response objects, which will be very similar, annotated with JSON serializable and part of the generated file. Make sure the name matches the file. Get users response, used for lists of users, will contain meta field, list of users, and the method from JSON. Second response is for single user, used when getting, creating, or updating single user. This one just holds one instance of user and from JSON method. Get comments response contains list of comments and meta object. Here you can see that you do not necessarily need to use your own data classes and just use map if you wanted to. But in my opinion, using the classes is more robust and consistent. Make sure you have the part keyword in every file with the name matching the file name, and all imports where necessary. We can then run the command flutter pub run build runner build. If everything runs successfully, you should no longer see any errors and have generated files for each data class, responses, and the client. And that's all for the API client using Retrofit. Now I would like to show you my favorite solution for getting data and calling the methods from app. For that, we use Riverpod Providers. Start by defining global variable that holds provider of API client class. Inside the constructor, return instance of API client, passing in the dia object, and provide base options, which tells the server we expect JSON. We don't need the base URL since it's defined in the annotation. Now create users provider, which we use to get list of all the users. It will hold instance of future provider using the auto-dispose and return type list of users. Inside the constructor, define async callback in which we access the instance of API client from previous provider using the ref.watch method. Inside the try catch, use the client to call getUsers and return the data from response object. In case of an error, just return empty list. To get single user, we need to know the ID. For that, we use state notifier from Riverpod, which will hold the state of selected user ID. Define selected user class, extending state notifier with the data type of state being int. Initialize the state as -1, which is invalid ID, and then define update method to change the state. Then create state notifier provider with selected user as its type and int as the type of the state, and return instance of selected user. Then we define future provider for get user response. Accessing the API client instance, calling the get user with ID and passing in the current state of selected user provider. This way, it will automatically respond to changes in selected user state. In this case, I'm not using try catch, which means the error handling is delegated to the UI. Either option is fine, it's up to you which one you prefer. For the UI, we will make view to display selected user information, list of users, and some button to test calling the rest of the API client methods we made. Inside main, wrap the app class in provider scope to be able to access the providers. Define app class, returning material class with homepage. Homepage will extend the consumer widget from Riverpod. Make sure to add scope reader as parameter of build method. Scaffold will hold column with 3 widgets: selected user view, action button row, and users list view. Start with selected user view, extending consumer widget. In build method, we use the scoped reader watch on user provider and call .when, which provides 3 callbacks. Data is triggered when we successfully get the data. The user provider returns whole response object, so get the user instance from it. Then you can access the data to display any information you want. Loading callback is called when the async task is being processed, so just return progress indicator. An error is in case something went wrong during the data loading. You can implement this however you want, returning empty size box or text with the error. Users list view will also be a consumer widget, calling the same when method on users provider. This one handles error inside the provider, but you still need to define all the callbacks. It returns the list of users right away. So inside the data callback, we use the users list to create list view. Item builder will return card with email and name. Separator builder will be just size box, and item count will be the user's list length. Loading and error will be same as previous. For the user selecting, we need to add gesture detector around the card. And on tab callback, which calls context.read provided by Riverpod, and using the selected users provider .notifier, we call the update passing in the user's ID. Also, make sure to add extended around the list view to display it properly inside the column. Last part of the UI will be the action button row. We don't need consumer widget here. Just make a row starting with get comments button, accessing the API client provider and calling get post comment with post ID. From the response we get the list of comments, and for each comment we print the body. Second button will call get comments with a query map, querying by post ID and email, and printing the response. Next, we call the create user, providing instance of a user, and you can print the response since it returned the user. And very similar will be the update button, passing in the ID and the same user with changed name and printing the data from response. Last button will just delete user by the ID. If you run the app, you will see the buttons and list view. Clicking on any of the list items, you should change the state of the selected user, and in turn call the get user and display their information. Click the get comments and you should see the body of comments for the post ID you provided. Clicking the Get Comments with Query Map will also filter by email. I just pick one from the responses we saw earlier. Create User button will return a user. Notice the ID don't match since they are generated by Cerebra. Use the generated ID inside the update callback. Click Update User and you should get the response with the same ID but changed name. Finally, call Delete User with the ID you just generated and you should see the message from callback. I hope this was helpful, and if you have any feedback or questions, feel free to leave a comment. Thanks for watching.